Stop it. Nagaya, stop it. Stop playing with it. Go with it. Let's go stand somewhere else. Nagaya, the computer is not plugged in. Girls? Pardon me, today? No, not yet today.
What computer is that?
This computer today. At least it was not.
What can I do?
Nothing. It's fixed or fixed.
It should be plugged in.
It's already plugged in today. It's already done.
Let's go at the same scale for the
140, 140, 150.
140 and the 801 also. It made massive.
Girls, pray, girls.
Waiting for a moment. One more is missing. Have you skipped every slide, sir?
I have yesterday. Of course, I won't be remembering much for the actual 51, but I'm scripting these two.
And what about
I forgot to script yesterday.
the other deck?
The other deck I also have another script, and this is the
Beautiful.
and this is the script for that.
You might make a comment about you putting his picture. Let's see what he says.
And it's a separate script, just where how I came up with the 7 and the 6. At least the AIPs. So.
You are telling them that AI is assisted you, isn't it?
Pardon me,
You are disclosing that AI assisted you do the research.
Oh yeah, I've told him that before. I've mentioned it before in the meeting. Yes.
Yes, Mama. Yes, Mama.
Ma, 853.
Yes, Mama.
Yes, right.
Your father has anything to make a call, right? Does he plastic all the others sword? I could be shocked by Anna's paper sword and lets them give Anna whatever he wants sword and think that the world all that he doing it now, Lord. That's Hopkins not causing any problems with Anna or Manfred, Lord. And let everything go well, Lord. Just in the asking. Your father and Anna goes on and any important promise to Manfred, Lord. Please bless Anna, Lord. And bless the words that come out of Anna's mouth, Lord.
As always, let Adam's people stand them, Lord. And let this only make Manfred more convinced that Anand is the best of the best, Lord. Please bless Anand, Lord, and let this call go well, as you made all the other calls go well, Lord. In Jesus' name we say amen.
Amen.
Dear Father, please bless Anand as he takes another call with Mr. Manfred. Please let this call be as successful as the others, and no one can get in Anand's way or with Manfred. Let Anand's papers stun all the people at ASU, and the people at ASU will be convinced that Anand is the best person for the job, and just me ask Amen.
Amen.
Heavenly Father, we thank you, Lord. We don't know. We can only speculate what's gone on in the background. But Father, you know beginning from end. You know minds. You know hearts. You know intentions. You know plans. Divisive plans, evil plans. You know people who mean well, Lord. So Father, we ask you to bring those people to the forefront for us. If Manfred is one of them, Lord, bless him abundantly, Lord. May you guide this conversation. Give Son composure and focus on what needs to be done. Let him be cool and calm. And if Manfred wants to share something, he may, Lord. So, Father,
Yes, Lord. Yes,
fight
Lord.
the battle for us, just like you went ahead of the Israelites. Father, we ask you to go ahead of Son and be his protection, his comfort, his refuge, and his fortress, Lord. As he moves forward, it's a very complex. The work is not complex, but people are extremely
Yes, Lord.
evil and just evil hearts, Lord.
Yes.
And they just do not mean well at all. So, Father, bless Son abundantly through all of this, and may he learn so many things, Lord, that he would not have learned otherwise. Give him, may your Holy Spirit rest upon him and speak through him. In Jesus' name we ask.
Amen.
Amen.
Lord, we thank you for this lovely opportunity, Lord. Pray, Lord, today's Son gains critical massive momentum, that his journey at ASU and beyond is just going to be paved with goodness and good people and others throwing themselves in front of evil and danger and saving Son's trajectories and paths, Lord, over time. Pray much, Lord, that this will be the seminal moment when everything shifts, Lord, that now Crow and Manfred and Mickey and these people will back Son. Like Mama prayed, we pray that this will grow to be a huge number of people across ASU and across universities across this world, across everywhere, Lord. It's a wonderful opportunity to learn so much, and for the girls to also learn so much, Lord. Even I'm learning so much, Lord. Thank you for this wonderful, wonderful blessing, Lord. Bless Son, let him have fun, and let's enjoy watching him have fun. Bless Mama's call as well. You know, she missed the call, but we'll catch up with her once this time she can watch the video. Jesus, let me pray.
Amen.
Time check.
57.
Very nice, sir.
Beautiful, son.
Thank you.
All the best.
Son, rocket, roll it.
Next one. Naomi.
The first slide in the deck.
Yes, done. Which one? Yesterday.
Next one. You can actually linger
Yesterday.
and
I'll let him read it out. Right? I'm not gonna read this out. I'm just gonna talk about the broad.
yeah. But that's a powerful slide. Because everything else is a subset. Even the next one is very powerful.
Yeah.
So as much time on the first two, and then the rest is just
Reason to. Such a slide.
Hi
Hello,
Nathan,
Dr.
how are
Lopico.
you?
I am well, Manfred. How are you? How was
Well,
your
running
week?
around like a headless chicken, but other than that,
How
too
was
many
your?
things deserve parallel attention, so, but it's all good.
Oh, good. How was your weekend?
Well, we got a few papers advanced, so I'm trying to finish 3 right now.
Okay.
All
Interesting.
interesting.
Yeah.
Not as mathematical, which makes it more difficult to write. You know, if you have equations, it's straightforward. So
Yeah.
how about you? How are you?
I've been well. I've been busy, very busy.
I assume so.
Yeah,
That's why we sort of have a conversation about how we get you on the PhD track. No?
definitely. Manfred, before we go on, just want to take a quick few seconds to update you that I did speak with Rahul
Yeah, good.
last week, and it was a very exciting conversation. We had a lot of ideas to kind of, because Rahul, he has a very broad base, right, in terms of making these robust systems. We were talking about how to make them more scalable, more future-proof, and
Yeah.
as we keep as we carry on with these projects, right, how to make them more value-centric and focusing on the sort of systemic change that we can deliver. So I just wanted to update you on that. He has given me quite a few documents,
Yeah.
including some agents that he's come up with, about 3 agents that he's designed out of
Yeah.
12
Right.
plus agents and whatnot, plus access to the GitHub repo. So that's exciting.
Mhm.
Just wanted to.
Yeah, I need to touch base with him. Last week there was too many parallel meetings. I had 3 visitors at the time I was supposed to talk to Rahul, so he needs to update me. But let me sort of give you some background that I will tell Rahul as well.
Of course.
So the big challenge that, and so no, back up. So yesterday, Michael Crope brought the whole executive committee of the university to Decision Theater.
Okay.
Well, just to explain, I had to explain to those people what Decision Theater actually is. So they got a demonstration, all very impressed, and I told them I face right now 3 main challenges. I can continue this Decision Theater as it is right now, but and we can even grow it, but we never can scale it under the current architecture. So scale is an issue, speed is an issue, and cost is an issue, because Decision Theater projects are not cheap. So in order to address those 3 issues, we need a new tech stack for the Decision Theater. And so this is what Rahul and now you are exploring with agents. Shri, who you have to meet, is exploring it from the data science component and also building AI solutions in there to more easily handle data sets. And the third component that we are exploring is this digital twin framework.
Yeah.
And the question there is whether we sort of build a custom solution, which I don't think is very feasible, or to what extent that NVIDIA Omniverse
Yes.
is a
So
potential solution, because with those guys we could even collaborate.
yeah, Manfred. So I got your email about the assessments or assessing
Yeah.
Omniverse and OpenUSD and whatnot. So I would like to share a few of my thoughts, if that's okay.
Yes, please.
Can I share? Can you see my screen
I,
or not
oh,
yet?
hold on. I always have to. I don't know why this doesn't come in automatically. Yeah, now you can.
I'm hoping you can see my screen.
Yes.
Wonderful. So as I got your email, Manfred, about
Yeah.
kind of assessing Omniverse and OpenUSD and looking at NVIDIA at its whole. And I know we spoke earlier about agentic AI and healthcare, I know
Yeah.
health systems, as some of the main kind of focal points that we want to look at. Of course, plus for decision theater, as you just mentioned, as
Yeah.
well as all across ASU, and how we can come up with these adaptive conversion systems, right? Because
Yes.
I do believe that I think we need to transition into active world modeling instead of static digital models, right?
Yeah.
The word I'd like to use is an operating system, and a decision theater operating system is, I think, something we should kind of pursue, right? As you just
Yes.
mentioned, this new architecture is something that would definitely be very valuable to scale, for speed, and for cost, right?
Hold on a second. I have to take this call very quickly.
Please take your time.
Sorry about that, but it's just that I have an AC technician coming to do a service, and he's about half an hour out. So,
No problem, no problem. So,
yeah. So operating system. Yes,
an
exactly.
operating system, I would like not just an operating system, but like a living, breathing type of OS for
Yeah.
decision theater is something
Hmm.
that I definitely think would be very interesting to pursue, right? And I would definitely want to see, as you mentioned, how NVIDIA plays into this, not just their Omniverse
Yeah.
framework, right? But they also have several other frameworks, such as Rubin, such as Cosmos, which can really kind of
Hmm.
scaffold this. And of course, with a high throughput, kind of dense compute, this
Yeah.
can really be made possible, right?
Yeah.
So I think this is kind of my thoughts that I kind of laid out here. Because I'm thinking about this not just for decision theater, but how this can also enable, directly, indirectly, across ASU, right? Because decision theater is a very influential piece of the puzzle.
Yeah, and so you really sort of hit it on the nail. So that what I find the limitation, or the current limitation, not necessarily future limitation, of Omniverse is that it can only handle issues that you can put within a physics engine.
Correct. Yes, and of course, sorry.
Now, and so the question is, can we build sort of a social engine, for humans or societies or social structures inside the omniverse?
Yeah.
And I am wondering whether there are, because they didn't say, but we can ask whether there are groups at NVIDIA who are exploring that, or whether they are content with their current physics engine framework.
Mm, yeah.
In any case, it might be a very interesting collaboration with some of the teams at NVIDIA.
Mm. Yeah, definitely. Of course, have you heard of NVIDIA Cosmos is another part of the puzzle, right?
Yeah.
It's meant for generating world foundational model environments, and that's something I think we should definitely kind of
Yeah.
look at. So at least the thoughts that I want to share with you today, and we can maybe find some other time to go over this in more detail if you'd like.
Yeah.
But this is kind of what I wanted to sort of go over, right? Starting with the NVIDIA piece. I mean, NVIDIA is a massive organization. They have, and as I saw some links you sent in your email, they have a massive number of products, frameworks, and libraries and
Yeah.
blueprints that we can really kind of use. And of course, we will use other frameworks as well. But Omniverse is. I'm sorry, you wanted to say something?
No, no. I think I'm just I'm impressed how you put this right to the nail. Where that question there is. That's
Thank you.
exactly the design, and so we see that the question is how can we expand Omniverse to objects that are not just physics?
Precisely.
And
Yeah.
but I really like the OpenUSD framework. I think that could be a way into this.
Oh, definitely. I mean, while we want to look at the social aspect of this, the physics piece is something that we cannot discard at all, right? And I think OpenUSD is the way to do that, right? By these
Yeah,
standardized schemas, we can have a very predictable model that, again, is resilient against hallucinations, right? By being grounded um,
exactly.
in these isomorphic models,
Yeah,
we can avoid the issues that arise from agentic AI, right? And of course, I
yeah,
love the Parliament of Agents sort of model that you explained when we first met with Rahul, and kind of expanding that to have not agents that just do, but agents that think. I think is something that we can definitely explore, right?
yeah,
Of course, we spoke about health systems, and that's something I am very passionate about, right, Manfred, as you know,
yeah,
and I'd love to continue and do that work across ASU. Right? But specifically for decision theater, there's so much that we can do to model it from the social aspect, from the physical aspect, even from the biological aspect of health, right?
yeah,
One example is, of course, you mentioned, like, if I remember correctly, it was the situation of an ER, right, where you have all these different specialized doctors. Who do you send where,
yeah,
right? I think one level further was not just simulating the social aspect of or the systems aspect of that, but the biological aspect of patients and profiles.
yeah,
Just an example of what we can do, right?
yeah.
And of course, I am very excited to be working with ASU. ASU, other than decision theater itself, is an incredible sandbox for this sort of engineering. Right?
Absolutely, yes,
So, um, can you see this piece? Can you see my screen, right?
yes, I do.
All right, 1 second. There we go. So, of course, Omniverse is a key part of what I think we should pursue. However, there are several other platforms at NVIDIA which I think we can definitely utilize, right? One, of course, is the Rubin platform, right? NVIDIA's Rubin, which is more of a neuromorphic Rubin platform. This is purely hardware.
Yeah,
So hardware and software, I think, are both separate things we have to kind of look at. As for the hardware piece, I think Rubin, which is it's neuromorphic, right? So a brain-inspired sort of architecture
yeah,
is something we kind of want to really look into, right? And as we have this, I call it computational metabolism. I don't know
yeah.
if that makes sense,
I like
but
that. Yes,
that can serve as our active sort of world modeling type of layer, right? This is not just a collection, and we want to and we standardize this ecosystem, of course, through OpenUSD. So I do know
yeah,
our time is limited, but this is kind of the details, right? Especially as one piece of this is that three-computer type of vision, right? Using Jetson, OVX, and GGX, because I did go into detail as to what NVIDIA's hardware capabilities are, and this would be a incredible sort of enabler for us.
yeah.
Are there any questions, Manfred? Like,
No, I think this is great.
okay, wonderful. The next piece I kind of wanted to focus on is the hardware, of course, is there, and we can branch out into so many different frameworks and libraries and blueprints, right?
Yes,
But specifically for Omniverse, looking at Omniverse, and everything around it is powered by OpenUSD, right? So when
Yeah.
I just mentioned this to you, but moving away from simply digital models to an active world model simulation, at a systems of systems type model, where there are several different subsystems that simulate or emulate different pieces of a system, and Omniverse is a massive part of that. Let me move to the next piece, and of course, I will share this with you. And if you have
Yeah.
any if you'd like to go over this in more detail, I'd love to. But
Yeah.
utilizing Omniverse is something I wanted to do through agentic AI, right? If we have I think the terms the words I was thinking of are a sort of cognitive orchestration hub across
Yeah.
several agents. And if we use, as I discussed with Rahul in detail during our meeting, the MCP or Model Context Protocol to ensure that every single agent, no matter its role, maintains a shared truth in its digital twins.
Yeah.
Right? Of course, one of the things is the idea of a recursive data loop, a synthetic data loop, right? Where we kind of close the sim to real gap, where the simulation identifies its own gaps and generates the data needs to train itself. Of course, this is a very new field, but that's something we can definitely kind of look into to make sure we are as precise as possible. There's definitely some aspects of this we need to be careful about, but controlled aspects of data loops is something we can look into.
What just occurs to me would be given the possibilities that you laid out. So if you have a first generation model and you then run decision theater engagements with stakeholders,
Mm-hmm.
and we basically capture this discussion with the stakeholders and what they suggest or find missing or do not quite trust in the first model, that if we basically capture that discussion, we can record it and then let agents process it and
Yeah,
use that feedback from the stakeholders to
recursively.
potentially update the decisions here, the model.
Yeah, and if we can do that in a way that does not, right, risk any, and as I was talking to Rahul, in a robust manner, that would be
Yeah.
incredible, and no one else is really doing this. So,
Well, or in a way, if you can do that even in real time, let's say, let's start streaming, but I guess the computational power would be there. So let's say
perhaps, yes.
you have a discussion, you capture the comments and the state of discussion, and while the discussion still goes on or moves to another topic, you have the agents in the background updating the model and say, based on your input, how about this?
Hmm.
See, because they can bring. Let's say somebody says, "Well, you have completely ignored the following dimension of the problem,"
Mm-hmm. Yeah.
which is always. This is the whole iterative approach of decision theater because we have to start somewhere, and we can't put everything that's relevant in the beginning. That's why we have those iterative engagements, and then our stakeholders say, "Well." Uh, the whole point then is okay. So how can we then say while we now listening to you and you brought up a new dimension, our agents are trying to incorporate that in another iteration of the tool.
Yeah.
It might not be in real time, but it might be much faster than we currently do it. But if it is in real time, it would be pretty damn impressive. No?
I think we
So
definitely can. Yeah.
you see where this is going. No?
I do. It is very exciting, and real time is definitely something we can consider, right? If we have the correct hardware architecture, right, then
Yeah,
that's
well, and
definitely
if
something we
real
can do.
time means 20 minutes, that's fine. You
Yeah.
still have, you can talk about something else, and then the agent sort of say, "Oh, I basically have now incorporated your suggestions into a new
Into the
model."
model, yeah. That's something exciting. Right?
Yeah,
So I know that we want to consider the social aspect as well, but
yeah,
OpenUSD, I was just doing some analysis, and it is incredible how much there is contained within OpenUSD that we can utilize, right? They have these, as I put here, standardized physics schemas, right? Which are
yeah,
these, and there's incredible number of these schemas which we can kind of utilize, because the physics aspect is an important part of mapping these social networks,
Yeah.
right? And I was just, whether it's the object property labeling or something I was looking into called Q codes, right? We can kind of have a digital entity and assign each of those entities like a sort of identity that a agent can query in real time. So that was something I was trying to kind of explore with this slide. And this would kind of prevent the, not just hallucinations, but the logical, I guess the word would be the logical sort of drift of agentic AI, right? When you have these unstructured 3D environments, and kind of ensuring that our simulations behave with mathematical predictability at a very large scale.
But so I always, when I haven't done a deep dive as you did here, but isn't the USD framework potentially capable? So if you have a well structured graph of social and knowledge interactions,
Mm-hmm.
then shouldn't that also work within USD?
It will, yes, but so that of course does work, but we can we can handle, well, we can utilize OpenUSD to handle both these structured networks as well as these unstructured sort of environments. That's sort of a twofold approach that we can have. Yeah.
Yeah, because if so the whole idea of the semantic web with knowledge representation is basically it's a knowledge graph. No?
Mm-hmm.
And if we add the social dynamics interaction, it's a social network. But both of this should actually be work within a USD framework if they are validated.
Yeah. Yeah, they would. Great.
So ultimately, that would be the way to bring the dimensions beyond physics and chemistry into omniverse.
We can do that. Yeah, that would work. Yeah. Definitely. And then, of course, a key part of our entire architecture is agentic AI.
Yeah, exactly.
Right? So that parliament of, I really do like that idea you suggested, or that just word of a parliament of agents, right? And I was thinking, and that is a multicellular organism, right? How they interact with different types of cells. And I was talking a bit about this with Rahul and the different types of agents that we can explore and the technical aspects of this, right? And of course, I think I explained this to Rahul, that instead of relying on a single monolithic model or set of models, we can orchestrate these experts, this mixture of experts, to kind of learn from each other in real time.
Yeah.
So just a few things, because there's so much potential here, but also we want to make sure there's no risk in the hallucination piece, and this is so decision makers can really trust these very robust systems. Right?
Yeah.
So this is just a few ideas to put together, but how to kind of avoid the issues that could arise from relying on agentic AI. Right? One piece was a recursive self-improvement loops, as I mentioned here, based on the critic verifier architecture that are used in other agentic systems somewhat. Right? If we have agents audit each other as well as keeping a human in the loop, that could be a two-pronged approach to kind of solve that issue. Are there any questions, Manfred? Anything I can go into more detail?
I'm following it with great interest here.
Wonderful. Now, of course, specifically the applications of this agentic AI architecture powered by NVIDIA and Omniverse and Rubin and OpenUSD is healthcare. That's, of course, something I am very interested in. One thing I was looking into and finding that there's not much done in this area was the idea of human twins, right? These whole body twins that can be used at varying levels of granularity to simulate a health system, right? Not just the social aspect, but the biological aspect of it. Yes.
Yeah, there I have an answer for you, because the reason why I was so busy last week is because I had Katie Berner visiting, who I know pretty well, and I'm just putting her website into the chat. She is one of the leading experts of visualization at Indiana University. And she's now involved in the project of the Human Reference Atlas.
All right.
And that basically is an idea to go from anatomy to histology to cellular to molecular to biomarkers and integrate all the clinical information. And the idea is to build reference humans. They're starting with a male and a female. The question is how many you then need, but okay, they start somewhere. And this is then an atlas, a visualization question. And then if you have any diagnosis, whether it's biomarkers or biopsies or anything else, you can always compare it digitally to that human reference so that
Yeah.
you see. So we are trying to work out a collaboration between the Human Reference Atlas project and us. Because what they don't have in their system yet is sort of a decision layer, how to use that Human Reference Atlas.
Yeah, and I think parts of this, if you look at points, let's see, points 3, 5, and 6 here, that could build on that concept. For example,
Yep.
the idea of trajectory steering, right? Like you said, kind of simulating these biomarkers, and not just that, but a sort of prescriptive model of what stimuli can be used to guide them back to health.
Yep.
And that's something we can definitely explore. And again, I went into more detail here as to how we can utilize NVIDIA's specific blueprints. And they have a massive library of blueprints, a repository of blueprints that we can definitely utilize. Right.
Yep.
So I'll share this with you.
Yes, please,
shortly.
yes.
But
I can obsess about it, but this is wonderful.
thank you. Of course, one other thing I want to look at before we move on to the idea of, again, the living decision theater OS was the capabilities that this sort of thing has across ASU, right? If we have the correct governance frameworks, as we discussed, the EU AI Act and more, and this idea of distributed compute across ASU can sort of have a massive impact, not just within decision theater for systems, but across ASU and all of ASU's efforts, whether it's the educational piece or the research piece or outreach. There's so many different applications
Mm-hmm.
as such, right? But on to one of the more interesting ideas that I think I had was the idea of a living decision theater OS, right? Which is the idea that I have in my mind is a continuous sort of self-optimizing operating system, for example, for state
Yeah.
leadership, right? For the governor's office, right? If
Mhm.
we, for example, if we continue to validate certain policies or legislation to eliminate unintended consequences across billions of virtual scenarios, which we can do with the hardware and the frameworks at hand, we can provide decision makers with incredible tools, right? Of course, this does require massive amounts of protection and guardrails, and we can have some existing frameworks that sort of come up with our own, right? If we have sort of decision guardrails, which are not really out there, they can be a sort of a safety net, like an epistemic sort of safety net,
Mhm.
right? And again, as I discussed with you in our first meeting, if we govern the latent space and stop hallucinations before they ever become text at all, that's something we can definitely look into, especially as we have these custom optimized models.
Well, and we can even design it. I mean, this was our discussion before that if we create an interface, so it's the living OS, that the values or the suggestions or the conflicts
Mm-hmm.
that we observe in the decision theater interactions as a human model interaction, that can be, incorporated into the scenarios of decision making. Because the interesting question would be, you can't just say all those policy questions can be optimized based on data. Because they are the whole purpose of policy, it's always, brings in human values, and sometimes human values are stupid, no? But that's what people believe. And so if we can sort of use that to get integrated in a systematic way into the range of possible model outcomes, then this is wonderful. I quickly have to let in my technician. I will be right
Please
back.
take your time.
Okay,
All right, Manfred.
I'm back.
Can you see my screen, Manfred? It says that my
Yes,
screen sharing is paused. Do you see
I see it. Yeah.
from 1 to 7, like these different boxes?
Yes.
Perfect, okay. Yeah, but finally, I think the last subject I wanted to talk about is the ultimate goal or the output of all this, right? Which is the idea of an adaptive convergent system.
Yes.
And I thought about this for a bit, that we can kind of integrate all sorts of data, right? Of course, I've put here genomic, social, etc. But there's so much that we can integrate to have this sort of system of systems, which is something I'm really quite interested in, right? Where we replace these top-down, very static rules, which are not at all what nature is like, with a very fluid system which evolves in real time. And this sort of architecture we can then apply to any number of applications, right?
Yeah, and that's when we can actually build in principles of complex adaptive system because we can put in adaptation and learning.
Yeah,
So
definitely.
if we put in those, give those agents ultimately a framework for adaptation and learning, then that wouldn't be simply a deterministic physics-based system. It would be one that would actually incorporate what it learns and what they learn from each other into its own structure. So always constrained within the parameters of physics. I mean, like, biological evolution.
Yeah,
It was always constrained by physics. I mean, there's no violation of physics in all of the organismal capacities, but the way natural selection and other evolutionary forces built the diversity of life is not deterministic in the sense of physics.
yeah. And
So
again,
if you build something like that into those parliament of agents, rules that are basically incorporating evolutionary and sort of developmental and
biological
cognitive
aspects,
learning
yeah,
dynamics,
yeah,
then we have a real organismal approach of a decision seeker system.
definitely. And of course, looking specifically at the hardware aspects of this, right? And this is
Yeah.
definitely made possible by, I was looking at the sort of governance hardware that NVIDIA has, and it's incredible. We can theoretically, right, monitor the health of a system very specifically
Yeah.
due to the parameters of these agentic AI systems being visible, and kind of provide targeted, whether it's centralized or decentralized, sort of stimuli to maintain this idea of the systemic homeostasis.
Yeah.
right, and regulating this entire society piece. That whatever interventions we suggest or we can improve on are adaptive or are as adaptive and resilient as these systems, which they
Yeah.
truly are. Right. So, are there anything else I can go over,
No, I
Manfred?
think this is great. So if you send me that, then I can say that my way of operating is I then start obsessing, and then you will get emails at 3 in the night and said, "What about this?"
I look forward to it. So, so
Yeah, no,
Manfred,
this is fantastic.
wonderful. So I did want to. I saw your note about the papers, right?
Yeah,
So
because what I do not want to happen is that you get bored.
never, but um, what did you have in mind for the papers?
So what I think, we have, you are a very unusual PhD student, as you might know, because you know more than most students who start their PhD, and you have many different ideas already. So we are looking at the very challenging big picture. So that what we have here in terms of the design of a OS for decision making, I think that's a great idea. And then we have this more theoretical idea, what if we turn the nodes of a network into agents, and then the network has two layers of learning,
Exactly.
inside of the agents and the network configuration, like a standard neural net. What would that give us? So those are the more theoretical question. The one is an applied question. But the way it's very helpful for people to get into their construction of a PhD is through sort of honing skills in writing well-defined projects slash papers.
Hmm.
Then that thing can then be incorporated in the bigger picture. And in one of the last times we spoke, you already mentioned that you have a few ideas of potential paper projects that you have.
Yeah.
So that might be an interesting way to get them a list of those and then see which ones do what and which ones could contribute to the overarching project that is emerging here. And so we could sort of work on some of those modular aspects of what turns out to be a dissertation. That was the idea behind that.
Of course. Yeah. And I do have a few thoughts about these. So if I could
Yeah.
share my screen again.
Yes, you can.
Can you see my screen, Manfred?
Yes, it's coming.
Wonderful. So yeah, your email did yesterday really did put a lot of thought. I've been thinking about this for several months, right back into even Q3 of 2025, and kind of what we can kind of.
Somehow it's still dark, your screen. Does it show up on your? It
It,
says
it, it does. Can you see? I do have a slide open. Are you able to see that?
no. I just see it was just black. Started screen sharing, but nothing came through. So let's try it again.
How about now?
No, same picture. I don't know what's going on here.
It says my
Oh,
screen. Can you see anything?
it says you started screen sharing and it nothing pulls up. So I don't know what that is.
It says it's paused. Let me try this. Can you see my screen?
No, but just walk me through and send me that then as an email.
I should be able to share it. Give me 1 second.
Well, we have been living on Zoom for the last 5 years, and it's always amazing what can still go wrong.
Yeah. How about now?
No, it's just the same thing. It started screen sharing, but nothing pulls up.
Okay, Manfred, I'm going to, if I can, very quickly leave the meeting and come back because
Okay.
I could put some effort into this. I would love to kind of. now?
No, same thing. I don't know what. Ah, now we go. Here we go. Got
Perfect. Perfect. Wonder what that was. But I do have numerous ideas that I've been considering, as I mentioned to you,
it. Hmm.
since mid of last year, honestly. So I kind of want to kind of break these down and kind of explore. Again, I'd like to preface that these are all just ideas that I have, concepts.
Yeah.
Some are very, very futuristic. So I think we'll go through them, right?
Yeah, let's do that.
So these are the seven sort of archetypes of
Hmm.
my ideas, right, for papers or for publications.
Yeah,
I kind of chose these because to me they at least they represented the idea of synthesis, right? They
yeah,
addressed the what I was getting up about some bit ago about the idea of the problem of synchronization, right? How a
yeah,
system maintains itself over time through active information processing is something that these address, right? Plus there is very little literature about these aspects already, right? Of course,
yeah,
the idea of these are all very high leverage research areas, right?
yeah,
Of course, I do have these other sort of pathways which I'd also love to explore, right? But there is a
yeah,
lot out there. And for example, if everyone is kind of looking into swarm intelligence, and as you know, there's a lot of sort of literature about swarm intelligence, right? And how that could affect the systems piece. The real breakthrough, I think, would be in the, if I go back here, to the sort of multi level governance of these
yeah.
swarms. So that's kind of my thought process for how I came up with these pathways. Right? Are there any
Hmm.
questions you have? Because this is
No, they are all great. I'm just thinking about what we can do. So if you go to the next one again, so the point five here. So I work with Jeffrey West and others at Santa Fe Institute on scaling applications. We will walk you through some of that. And so there is a lot of work done on urban scaling by Louis Bettencourt, Jose Lobo, and others. And we have some interesting ideas in the using that framework, both for understanding the historical development of societies as well as the future. Sort of think about it this way: that what happens, or that we are now in a transition where the technosphere, sort of the all-encompassing global network of infrastructure, basically means that we move from multiple urban centers and societies to one global city. And what are the consequences of that? So that you could really identify very well under that urban scaling and metabolic growth framework. And if it's true, I'm always a skeptic, but it looks increasingly likely that I have to be end of March at a highly political meeting in Hong Kong.
okay.
The context is that there has been a long-standing discussion between the American Academy of Sciences and the Chinese Academy of Sciences, focusing on urban sustainability. So now the political context between the US and China becomes even more problematic, but there seems to be an interest on both sides to continue this. So
Mm-hmm.
now I brought in the Max Planck Society into those discussions, so it's now a three-way discussion. And then it became for the two governments of the US and China to not be too overtly talking to each other. Um, the American side has sort of designated ASU as an organization that should pursue that, and on the Chinese side, it's the University of Hong Kong. So we will figure out if this meeting happens. But if it happens, it's exactly about point number five here.
Yeah, Manfred. I also want to kind of look at this as well because I think while the other set of seven is what I really want to focus on as the future, right, and what we should kind of
Yeah,
pursue. these are the first principles, basically, of complex adaptive systems. Right? You can't have digital twins without metabolic growth and power scaling.
Right. I mean, and I think, and then the focusing on cities is a very concrete question that where there is a very strong research area that we are contributing to. So there is a whole tradition. So this is why I said, okay, let's figure out how to find a topic where one can develop a series of papers that connects to an ongoing uh, important research and policy area and sort of urban scaling metabolic growth and then what is the future of the technosphere and of a human civilization on this planet. So there were, over the last decades, everybody was saying, well, globalization is inevitable and we will sort of converge on one global society. Right now, on the political side, that has a big backlash. But on the actual implementation, whatever the policies of the day give you doesn't change the fact that our technosphere has become so integrated that de facto we live in a global city.
Yeah, yeah, and
And
that
you haven't figured out what that means.
not yet. Yeah. Well, that's like the
And
sorry.
and then they go to multi-level governance and create because that's exactly what we need to figure out how that actually can work within that now constructed niche of a global city.
Yeah, I'm really excited to see. I have several ideas across these topics,
Yeah.
but
So we're just
I
sort of mapping how they all are connected, and
they
then of
really
course on the
yeah. If
technical
that's like the
side,
mechanistic tier, this is more of the synthesis tier, right? And
exactly, yeah,
there's very. I was looking into the literature, and there's very little out there. And I think these papers in these fields are very hard to find because they're currently being written, right? And very few researchers are brave enough or caffeinated enough to to kind of go at these interdisciplinary fields, right?
yeah, and then I personally am very interested in your point four here too, because that is really on the mathematical side where this needs to go.
Correct. Yeah, that's something I wanted to kind of look at because I was trying to find enough mathematically based literature for complex systems, and I didn't find as much as I'd like to see. So,
Yeah, no, no, this is also because the complexity theorists have not really gotten beyond networks.
okay. Well, looking
Well,
at,
some of them do, but not the majority, not.
yeah, and that's something we can definitely kind of look at,
Yeah.
right?
Now
So,
this is wonderful. Okay,
thank you.
now we have this.
So going into the specific ideas that I had across
Yeah,
these 7 very exciting, as I put, greenfield sort of pathways, right?
yeah,
Let's see. So this would be kind of the first of the 7, right? Which is again the idea of these socio-technical systems, these mirror worlds,
yeah,
right? Of course, through multi-enterprise synchronization, right? Moving
yeah,
beyond the idea of static visualization
yeah,
towards the idea of recursive inference, recursive variational inference is something we should kind of look at. And that's what I'm trying to do across all these ideas. So I'm
yeah,
just trying to make sure it's clear. But each of these 10 is an idea for a publication or a paper that I do have.
yeah. Hmm.
Right? And something that all of these kind of look at is the idea of the information bottleneck, right? We need
Yeah,
to, the idea of developmental sort of, I think the word would be isomorphism, and identifying minimal statistics required for a digital twin to mimic decision making, right?
hmm,
Without the computational overhead is something that all
yeah,
of these kind of touch on some aspect or the other. Of course,
yes,
the next piece of this is the idea of applying thermodynamics to governance, right? And I would like this. I really enjoy the field of the idea of statistical mechanics and applying that to legal precedents, to governance, to bureaucracies is something I'm quite interested in, right?
hmm,
Where is and
yeah,
this is something that's very very applicable to places like again the governor's office, right? Where what is the tipping point of redundancy in the administrative aspect of this, and where does it compromise the functional output?
Yeah.
Right? If information being erased is a thermodynamic process, and if we look at it in that type, with that manner of speaking, then there's a physical price that can be assigned to regulatory complexity and red tape and the cost of bureaucratic processing, right? And that's kind of what each of these looks at in its own different matter, whether it's the idea of entropy with Landau bounds or etc. Right? So again,
Mhm.
these are 8 papers that are under this. Are there any questions, Manfred, that I could perhaps
No,
answer?
I see that they are all very interesting. I think I was fully anticipating that our biggest challenge will be selecting a pathway where to start.
Definitely, and of course these are various ideas.
Yeah,
Some might be applicable right now, some might be applicable later, right?
yeah,
If we look at that, so this idea of, again, this is very interesting to me, is the idea of evolutionary dynamics, right? I know that's
yeah.
something you are very
They are
passionate
really,
about,
yeah,
right? So, like, I want to look at these sort of artificial simulations that obey the universal scaling laws, the metabolic scaling
yeah.
laws, right? The technical focus, of course, on this is the idea of phylogenetic drift. And by modeling these organisms digitally across these various different methods, that's something that we can really bring a lot of new thing in, and kind of building these mathematical models again in this aspect and the others.
Yes.
Right?
No, I think I see all of that. Uh, yeah, I think they are all nicely interconnected. Uh, yeah, a combination of 5 and 7 would be an interesting one to start.
Definitely. As well as I did want to kind of think about both 2 and 6, meaning 2 and 6.
Yeah,
I believe 2 and 6 kind of feed into each other, and even
yeah, no,
five and
and
seven,
5 and 7 do.
two
Well,
and
4 and 7, 5 is sort of behind all of that. No, but they're all nicely interconnected.
yeah, yeah. Of course, the next topic, I think you mentioned this, right, is of course, again, the mathematical piece of global networks. Right, I was looking into I'm pronouncing this correctly, the Olivier Ricci curvature, and that's so
Yes.
interesting to me, at least, because that can be applied to so many different aspects, whether it's the supply chain, like in number 2, or it's in markets, or it's in health systems. It's really incredible, right?
Yeah.
And if we can kind of, so all of these, at least the thought process that I had for the across these ideas, was the idea of tracking the propagation of stress throughout these systems, right?
See that the number 2 point here is interesting because Peter Schlosser and myself we have too little time, but we have this ongoing discussions where we say that the framework of tipping points is not particularly helpful in the debates about the future, even though it gets all the attention because it basically projects the challenge into a very low dimensional problem.
Mm,
And so the idea would be if you look at, let's say, the global Earth system, not through the lens of there are dynamical systems in there that have a tipping point and so that we have to worry about, but look at it as a or high dimensional curvature.
mm-hmm.
And then the system gets stressed. That means there are different stress points that affect the curvature. And but that means yes, and sometimes changing the curvature can have a similar effect that you describe as a tipping point, but it maintains the intrinsic connectivity of the system and gives the possibility of compensation that is not within the framework of tipping point. Because the tipping point framework has sort of the time component, and then something dramatic happens and the system is in a different state, and that's it. Whereas if you look at it in a much higher dimensionality, then you can say, well, there's something happening here. But think about this as this volume or the surface of the volume then bends and adjusts, but that means there's a whole different way of understanding what the new dynamical stable equilibrium can be than just looking at the low dimensionality of a tipping point. And that basically could be done with this Ricci curvature.
Yeah, that's good. Was another piece to the next kind of idea that I had, which is across these agent networks, and of course, whether it's using agentic AI or not,
Yeah.
right? And kind of mapping you when you have these massive agentic populations, instead of kind of point-to-point tracking, if you optimize behavior based on the collective distribution in the field.
Yeah.
That,
Yeah.
I think I lost. But that's something I want to definitely, again, consider. I'm hoping you can see my screen.
Yes, I can.
Okay, it's giving an error for a bit. But yes, again, the next piece is the idea of epigenetic memory.
Yeah.
And again, this entire set of archetypes, if you will, that I have is about this interdisciplinary synthesis of systems architecture with whether it's biological concepts or physics concepts such as thermodynamics. Right? And sort of applying that, there's no one else is really doing this, and this is kind of a very exciting set, right? This is specifically organizational systems, and this kind of plays into, again, my interest in the world of business and strategy and whatnot. When you have these sort of systems and you map these, again, what all of these kind of touch on, and in some aspect or the other, is the idea of an adaptive response curve, right? And if
Yeah.
you quantify plasticity in, for example, in corporate structures, to identify mechanisms of memory retention, right? Because change is not as easy as we think it is in any corporate structure, organizational system, in anything. And kind of quantifying that is something that I want to kind of look into through these mathematical models. Of course, the final piece that I'm looking at is, again, cross-domain, right? So this broadly I'm thinking of because it will allow us to scale these multi-domain sort of digital twins without the growth of, like, the exponential growth that is inevitable when it comes to structural complexity, right? We want to have these simpler models which still are across domains but preserve the effectiveness of these systems models, right? So I'll just go over, and we can touch on everything in more detail, right? Sort of
Yes,
each
if
of
you
the,
send me that too next to if you send me both text, slide text, then I can go over that and we can highlight what I think would be the best starting point.
of
Because the
course,
problem is with writing papers is that you have to reduce the dimensionality to a linear system because writing a paper is a linear function in time.
yeah.
So one dimensional here.
But let me just walk through, because I did put together a lot of my thoughts across each of these papers, right? So
Yeah.
if we just go paper by paper, let's go through, for example, the first, right? The idea, again, the idea of digital twins.
Well, let's do that the next time because in 2 minutes or so my next meeting starts.
Oh
And
my.
but stay on here. I introduce you to one of my former students who is now a research scientist because we have
That'd be
to talk
wonderful.
about something. So you'll meet somebody else. And that's
Okay.
sort of the other thing, Nathan, that we have to sort of coordinating, but I think it involves also coordinating with your mother a little bit because we need to find a few times where you can start meeting people here.
Yeah, yeah. I was talking about her, and she said we could be able to come in sometime. Were you thinking of a
Yeah, no,
specific?
we should. And so maybe I don't know whether well, we schedule our next meeting then, and maybe she can join us for a few minutes and can give us or can give me her constraints so that we figure out what would be a good time to schedule a few meetings.
Maybe, yeah. Because I also have some sort of appointments that are pending at the Global Features. Yeah.
Yeah.
So kind of combining that.
And Mickey and I talked, and so we are trying to coordinate this.
All right. Then yeah, of course.
Because the idea would be, if well, that's just a matter of coordination, do it efficiently so that you don't have to drive back and forth all the time. It's a waste of time.
Yeah. Well, man, of course we can go into this in more detail. But I just want to kind of very
Yeah,
quickly.
let's go start going, and Derek will just join in a minute or so.
Right, but if you can see, this is each one of my papers, and
Yeah.
we can go into a lot of
Yeah.
detail. I'll just keep.
Yeah. Okay, yes, now this is interesting. Yep. Mm-hmm.
Yeah, I know your schedule is packed, right? But
Yeah.
we could definitely.
No, I think like you, I can pretty glance a whole screen and more or less at once. So allows us to read a lot.
Yeah.
Yeah. No, there are a lot of important things in there. Yeah.
Just I've had these thoughts for a very long time, for
Yeah.
over 6, 7 months now. So
Yeah. So there's Derek. Hello. Hi, Derek. Meet Nathan.
Hello, Nathan.
hi Derek, nice to meet you.
So I think I told you Nathan is my newest PhD student
Okay.
at the wonderful old age of 17.
Oh my gosh.
So we were just discussing some of the paper ideas that he has. So, and Nathan Derrick was a former PhD student of mine who is now working as a research scientist, and
How wonderful.
we did a lot of interesting work together, including that whole series of scaling in trying to understand the transition to the Anthropocene. That's the work with Jeffrey West and Chris Campus at SFI.
Oh yeah.
So, Nathan, he is one of the people you should meet in person when we organize those visits.
Definitely, I do look forward to it, Derek.
Yeah.
Yeah.
Yeah, that would be great. Yeah, if you guys aren't done finishing up,
No,
I
no,
can-
I think, Gary, this would be an endless conversation, all productive. So I think we came to a natural conclusion point, and Nathan just sends me this, and we will take it from there. Nathan has too many interests.
Yeah.
So we're trying to figure out how to sort of linearize a very high-dimensional complex system that is represented in his brain and his interest and start somewhere.
Okay.
Yeah.
That's the challenge here.
Yeah. No, I mean that's a great place to start for sure.
Yes.
Thank you. Yeah. Well, I will let you guys get to it, but thank you so much, Manfred. Derek, I hope to meet you soon. Manfred, thank you so much for your time.
And Nathan, send me those 2 dicks, please, so
I
that I
will.
can start obsessing.
Definitely, of course.
Okay. Thank
Well,
you.
Goodbye to both of you. Bye.
Bye.
All right. Nice to meet you, Nathan.
You as well, Derek.